Who knows how to spell MVVM? All right. So, any Silverlight developers here? WPF? Well, that's about 50-50. Cool. I'm going to do my stuff in WPF, but everything that I'm going to show you in this next session, this next 75 minutes, is going to apply to both. Okay? There's really, if I come across something that triggers something in my head that this doesn't work in Silverlight or it's different, I'll mention it to you. But to the best of my knowledge, everything's going to be available for both. Has anybody not yet jumped on the XAML application bandwagon with one of these two technologies? What the hell are you waiting for? All right. Is anybody here? I'm asking. I got to poll the audience for all these things to know exactly how to steer this thing. Is anybody here kind of still a little shaky on how XAML data binding works? Yep. Okay, so XAML data binding, I'm not going to make this a full tutorial on data binding, but I am going to go over some of the basics. I have to. There's no way in the world I can jump into an intro to MVVM talk like this one and not discuss some of the intricacies of data binding. And the main thing that I got to say is XAML, the data binding aspect of XAML is not a complicated thing, but it is personally responsible for the slow adoption rate of XAML technologies. And when I say XAML technologies, obviously I'm talking about WPF and I'm talking about Silverlight. And if there's one characteristic of any of those technologies that drives people to, not drives them away, but drives them to, I'll deal with it later, I'll learn something else right now type of attitude, it's the data binding. And the funny thing about the data binding is that I can guarantee you it is far more intimidating than it is complicated. It is not a complicated animal. It breaks down to very simple things. And I'm not going to get into the details of the ground up in data binding, but I'm just going to jump right in and start using data binding and explain it as I go along. And you're going to get it. You're going to see that, like I said, the intimidation factor far exceeds the complexity. Now, something else about this session, okay? This is what we're going to talk about. A little bit about data binding. We're going to discuss what MVVM is. The big one is like, why? What is MVVM going to do for me? That's a big selling point. I need to sell you on this technology. Then we're going to jump right in and implement the pattern. Now, I got slides for everything, and then I got code for everything. And unless you guys have a real fanaticism with Microsoft PowerPoint, I'd like to stay in the code as much as possible. Anybody here have a problem with that? What are you guys, dead? It is 4:30, isn't it? Does anybody here have a problem with that? Thank you very much. All right. Now, the slides are going to be great because a lot of the stuff that I talk about in code I cover in the slides, but when you take these slides home and you look at them, they'll give you a good frame of reference. But I'm going to try to stick in the code as much as possible. I'm also going to really be, I can't say the word I'm thinking of, courageous. I'm thinking of the word starts beginning with the letter B. I'm going to be courageous and do all the coding from scratch, and hopefully everything will work out okay. So one of the reasons I'm doing that is not to show off, is to show you that what I'm going to show you is not really complicated. It's a pattern, and I'm going to show you how to follow the pattern, and it's not rocket science. It's not a lot of intricate coding. A lot of it is coding that you're used to doing. So we're going to talk about implementing the MVVM pattern, and then we're going to get into commanding. These are the two primary things we're going to cover here, because this is going to be the root of what MVVM is. And then I'll talk about some more advanced stuff like unit testing and advanced features. If I finish with 15 minutes left over, I got some cool stuff that I can show you. This is one of these topics that, like, if you give me 3 hours, I can just keep showing you cooler and cooler and cooler stuff. It's a very neat topic that hopefully I'll have a chance to at least show you one or two cool things at the end. So data binding is XAML. I mean, this is, you know, the big difference between WPF and Silverlight is that in WinForms, and compared to WinForms, is that in WinForms, we did a little bit of data binding here and there, right? We data bound some controls, we data bound grids. We injected data binding where, number one, we thought that it was injectable, and number two, where it was allowed, because not everything was bindable in the world of WinForms, and the same thing applies to ASP.NET. Who's an ASP.NET developer? What about ASP.NET MVC? All right, now see, you guys are going to feel a little more at home, the MVC people, because in MVC you can bind the model directly to the whole view. And this is very similar to what we do in XAML. In WPF and Silverlight, data binding is the way to go. I mean, this technology lives and breathes binding. And if you do it right, it can be it really can be your best friend. Sadly, it's one of those technologies that needs to be embraced entirely. You need to kind of just drink the Kool-Aid and do it the XAML way. And what's happening, and the reason I'm still talking about MVVM to you, is because most people learn WPF without learning what the model view model pattern is. And the two things go more hand in hand with each other than you can possibly think. Because if you eliminate MVVM from the world of WPF and Silverlight, what you're left with is a conventional code behind model, just like what we have in Windows and we have ASP.NET, where you have buttons on the screen and you double click on them, you got a click event, you got a selected index event, that kind of thing. And that's not, it's not really bad, but we have such a better alternative with using this pattern that there's a much, much better way to go. Now, I'm gonna show you some samples of data binding, and I'm gonna jump right to the code in a second. The reason, one of the things about MVVM is to provide a source of binding for the view. So you can design your UI. One of the ways I like to put it is so you can engineer your UI without your UI. Now think about that statement. I know it's kind of really weird, but when you guys design an object model for the middle tier, for your business layer, you design your model. You design some objects, how they relate to each other. You design inheritance chains. One object inherits from another. This may implement this interface, and you have a lot of abstraction here and there. You implement a lot of different patterns to get your business tier to look and operate just the way you want it to. But we really can't do that too much with the UI, because in the conventional sense, the UI just gives us a view with a code behind, and we can't really do a lot of inheritance with that code behind. We're not really subject to a lot of interface implementation with that code behind. We're very limited in what we can do. Well, with MVVM, we can concentrate on designing the UI as if it was a logical layer without actual visual elements attached to it. And later on, through the magic of binding, we can bind the entire UI. Now, if there's time permitting all the way at the end, I have a cool exercise to show you that really brings that statement to life. But for right now, so this couple of slides that I have is YAML data binding. I'm going to jump right to this code and show you exactly how this works. I have a model here. As you can see, look at my project tree. I got a common project. This common project's got these models that we're going to be using for the entire 75 minutes. Now, the first one's called Superhero. Why? Because I got tired of doing person and contact name and first name, address and stuff. I had to do something cooler. So I decided to go with superheroes, right? So we have a very, very simple object here. Think of this as a business object. And the object has two properties in it, name and secret identity. And then it's got the stupid static method that's going to give us a copy of it, right? So what I'm going to do is that I'm going to take this view. I got this view right here. There we go. Okay, as you can see, the view has a couple of text boxes, one for hero name, the other one for secret identity, and then I got a button that I'll describe in a second. What I'm going to do is that I'm going to instantiate a copy of that object, and I'm going to bind it to this view. This is the way we represent data on the screen. I'm going to give you a few takeaways from this. Every time that I give you a quote that I think is going to be important for you to kind of engrave in your head, I'll let you know. Here comes one. If you find yourself setting control properties in code, you're doing something wrong. So for example, in WinForms and web forms, you're very used to having a name on this text box, like txthero, right? And you say txthero.text equals something. If you find yourself doing like that with anything, whether it's a text box, a label, a button, any property, step back and take another look at it, because MVVM will replace that kind of coding. What I'm going to do here is that I'm going to set an instance of that superhero object to this view using conventional regular binding. This is just to show you some binding examples, and then I'm going to describe where this falls short and why MVVM comes into the picture. So for right now, this is a conventional two-tier application, or it would be three-tier if we had a database, but we have a view that is going straight to a business object. And this is something that I think everybody in this room is probably used to. We're all good developers. We all program with at least three-tier architecture. Am I correct? Database, middle tier, and front end? Humor me. Lie to me if you don't do it. So I don't, because if I find out who you are and you're only doing like, view to the database, I'm going to blog about you. I'm going to take a picture of you, and your life is going to be over. So we do minimal three-tier architecture, but we're used to just the view going right to the business tier. No big deal. But there's certain areas where this falls short. Now, as you can see, I have this view here, and I have the two text boxes right there. And the text property is binding to the names of two properties, name and secret identity. This is XAML binding in its simplest form. It really is as simple as this. What happens here is that these text boxes are expecting later at runtime an object assigned as the binding source for this view, and it hopes to God that that object has two properties called name and secret identity. And if it doesn't find them, it's just going to show blank, so it's very loosely coupled. It's not going to throw an error. And at compile time, it does not have compile time checking. This is a good and a bad thing. It's a bad thing because if you spell like I do, you're going to make all sorts of mistakes. But it's a good thing because you're completely decoupled from what's going to be behind the scenes. I don't have to make a decision about what object I am going to bind this to until much later. All I have to know is that this view is expecting me to bind to two properties called name and secret identity. Where they come from later, it doesn't matter as long as it finds them. So what I'm going to do is the following. I have a main window, of course. This is going to be the window that I'm going to be running the whole time. Now, this window has nothing but a placeholder control. As you can see, it's just a content control, okay? So I'm only going to show you this once because it's the same pattern over and over again. What I'm doing here is that in that window, I'm going to create my superhero object. I'm going to create that view that you just saw, which was a user control. And then I'm going to bind the two together. And the way the XAML data binding works is that and this is where it gets really cool and really dangerously flexible, is because in WinForms and web forms, certain controls were bindable or had binding compatibility, and certain properties of these controls had binding compatibility. In WPF and Silverlight, everything is bindable to everything else. So it's this massive many-to-many relationship that if you're not careful can get you into a lot of hot water. But it's very, very powerful. The way it works is that as opposed to the data source property that's probably familiar to everybody in this room, every control in WPF and Silverlight, every control, we'll just say XAML from now on, every control in XAML has a data context property. And that data context property can be set to any object that you want or collection. So it's the source, that would be binding source. And whatever object it is set to, its properties are available for binding, and its entire object tree is available for binding from the control that you set it on down the visual tree. This is an important statement. The visual tree. You're going to read, every time you read a book on WPF and Silverlight, it talks about the visual tree. When you build XAML-based applications, you're essentially building a visual tree. You're literally building a hierarchy. XAML is an XML-type language, and XML is hierarchical in nature. So as you can see, we start at the top, user control. That's an element. That's got a data context. Inside that, we have a grid. That's an element. It's got a data context property. Inside that grid, we have a stack panel. That's an element. It's got a data context. Inside the stack panel, I got two labels. A sibling to that stack panel is another stack panel. So those two are in the same visual tree, but they're not a child of each other. They're siblings. Then inside that second stack panel, I got something in its visual tree. Now, in this piece of code that you saw right here, I just showed you where I set the view itself, that user control. This is what I instantiated right here, which is this thing right here. I set the data context of that view to my superhero object, which means any property tree, the entire object graph of the superhero object, the instance of it, is going to be available for potential binding from this level and down the visual tree. If I wanted to, I could have given this grid a name by saying name equals, because in XAML, if you don't need to address something by its name, you don't have to give it a name, so get rid of it. Don't clutter up the screen. I could have given that grid a name and then said whatever the name of that grid is, .data context equals. And now those properties would be available to this grid and its visual tree, which means they would not be available to the user control. I could have done the same thing to the stack panel, and now only the stack panel and the contents would have access to that data context. You see how that works? Now, in typical binding technology, binding situations, whether you're using MVVM or not, you set your data context at the top level. Now you understand why I said the MVC people will probably feel a little comfortable for this. You guys, if I'm not mistaken, at least with Razor anyway, you can set your model at the top of the view and then just bind everything down, right? Works exactly the same way, even though there's no real visual tree in MVC. So what I did is that I set that superhero object to the data context of my user control, and rest assured, the name and secret identity are going to be accessible. And now, if I run this thing, you're going to see that Superman and Clark Kent showed up at the text box. That right there is probably the simplest example I can give you on XAML data binding, and this is XAML data binding in its simplest form. Everything else that makes it more complex is just added characteristics of binding, like which direction's the binding. Is it only one way? Is it two-way? Does it change when you do property, when you click, when you do keyboard clicking, or when you lose focus? So there's different characteristics that you can add to it, but this is data binding in its simplest form. Does it make more sense to you when I said that it's far more intimidating than it is complex? It really isn't a very complex animal. Now, look at this button, because this is where we start getting into MVVM. And I'm going to stay in the code. I don't think I'm going to go back to the slides until probably later. So I did a button click here on this. So I'm going to go into my code behind. And in my code behind, I'm pulling the data context out, because now I want to address that object programmatically. I'm now going to say hero.name equals Miguel. All right? Now, you would think that in a data binding scenario, changing the object would change whatever it's bound to. Is that a fair assumption? Yes? No? Okay. Who said that? All right, shut up. You know where I'm going. Now I'm going to click the change button, and nothing's going to happen. Now, the reason nothing happened here is because we're not doing any property notification. So I got to explain to you what property notification is, because here's the little segue into the world of MVVM, because property notification is not an MVVM thing. As a matter of fact, every good business layer that you write should probably have property notification built into it, because the idea behind, separation of concerns is that the people writing these different layers may be two different people. So you may be writing a business layer, and we haven't talked MVVM yet. You're writing a business tier, and you don't know what it's going to be bound to later. It may be used for a web application or a Windows app or a Silverlight app. You really don't know. So you want to give it as much functionality and make it as solid as you possibly can. In fact, if you use business frameworks like Spring or like CSLA, for example, they have all this property notification built into them. So let me explain to you what property notification is. This superhero object that you saw here has two very, very simple properties. What happens is that when you get them or when you set them, all you're doing is retrieving or storing a value. There's no other functionality that's taken place here. And WPF wants a little more functionality. What happens is that WPF and Silverlight will take, when you set the data context to something, it will take that something and test it to see if it implements a certain interface. This interface is called iNotifyPropertyChanged. And if your object that you're binding to implements this interface, it wires itself to the one and only member of that interface, which happens to be an event. It wires itself to that. Now, it hopes, it doesn't do this automatically, it hopes that when you set a property programmatically in your object, you're raising that event, because that's what's going to notify the view that you just changed this property. And then WPF will say, okay, now that I got that notification, I'll take care of the rest. I know how to change it on the screen. You don't need to worry about it. But it needs to receive that notification. And the problem is that you can't rely on every business tier being this intelligent. In fact, I have a very stupid business tier here, because all it has is a couple of public properties with getters and setters. There's no notification taking place. What if this business tier was in the real world, and what if it was given to me by a developer in the form of a DLL? And now I have no access to the code. Now I have to compensate for this. You see where we're starting to throw a wrench into this whole thing? Now we have what we thought was a really good business tier that has all of the properties of a superhero, and I can bind them to a view and everything looks beautiful, but then I start changing something in the object and nothing changes in the view. We're falling short here. This is one of the goals of MVVM, to compensate where the model or the business tier, call it what you will, they're kind of the same thing, where they start falling short. And you may have a business tier that is more intelligent, which can lighten the load of your view model layer. And I'm going to give you an example of that. In my first example, I don't have that. I have a very light business tier, so I'm going to have a heavier view model. Now, as far as what the view model is, let's change over to the code real quick, because I got some definitions here. So view model this is a pattern that was made specifically for binding. The idea here is that the MVVM layer, the view model class, is going to serve as your only point of binding for each view. If you do it right, in my opinion, every view should have a view model. And that view model is set to the top level data context of the view, at the user control or the window level. And anything in that view is always going to be addressed in the view model. Now, your view model can wrap 3 or 4 different things. I mean, think about it. Nothing says that you could only have one business object per view. What if your view is comprised of information that comes from 5 different business objects? Now you start to run into more shortcomings. You're like, well, how's WPF going to bind to like 5 or 6 different things? Now you got to set data context all over the place, which you certainly can, but it starts to get dirty. And then we start to go backwards in time to, remember the old spaghetti codes? The old go-tos and stuff like that? Well, we don't have go-tos anymore, but we certainly have the potential for spaghetti code. So the view model becomes our single point of binding for the view. And what it does and where it gets its data in order to serve it to the view shouldn't matter. In my case, it's just going to get it from one source, one business object. So this class provides the single binding source for the whole view. It encapsulates all of the logic for the view. This means that it encapsulates both state and behavior. And I'm going to get into behavior later for commanding. Everything that we're doing right now is just state. So we're providing properties that the view is going to show. It's very loosely coupled to the view, which means it's not until runtime that the view knows what view model it's going to be bound to. So during compile time, all of those binding tags that you saw, they don't get compile checked. I can misspell that to my heart's content. It's not going to tell me anything. At runtime, it's not going to show anything. This is what it looks like. As far as a layer, where in the architecture it literally is right in between the domain layer and the view. It's just another layer. It's not a replacement layer. It's more of an overseer layer. In some cases, the view model can go side by side with the views in the same assembly. In my opinion, and in most cases, it should probably go in its own assembly. That's up to discussion because there's a lot of very intelligent people that do not agree with me on that, but that's fine. It's a very, very loosely interpreted pattern. And that sounds like a dangerous thing, but that's the God honest truth. If you follow a couple of guidelines, how you implement the pattern is really subject to a lot of interpretation. Everybody here will agree that programming is a very, very personal art. We all have our own signature, we all have our own coding style, and we all have our own patterns and our way of doing things, and it doesn't necessarily mean that somebody is right or somebody is wrong. Except Sam over there, he's always wrong. Buddy of mine. View model really, really brings that to a whole new level, that statement. Because there's 100 different ways. And I'm going to show you a couple of ways, because I can't just leave you with one way of doing things, because you're going to see others when you go out there and read about it, and you're going to wonder, well, why the hell did he show us this and not this way? So I'm going to show you a couple of ways of doing things, okay? Let's talk about the goals of MVVM before we go back to the code. So the goal of MVVM is to make the view state-driven. What this means is it's a little difficult to really describe. Because we seem to be on this everlasting, never-ending quest to put as many things as we can in front of the words driven-development. You ever notice that? Something driven development. Every year we see something else, and we're going to run out of letters in the alphabet. So I'm here to add one, because we don't have an SDD yet, not to be confused with STD. Those are strongly typed data sets. We don't like any of those, right? So SDD. State-driven development. So it's about the view model exposing things to the view. So if the view has a requirement, the view model changes properties to rebind the view and satisfy that requirement. That may be turning some things off and turning some things on. But it's all about the state triggering things on the view. And that's part of the job of the view model. And the exercise that I have at the end of and I'm going to make sure that I have time to show you, because there's probably 2 or 3 things that I can show you, but there's one that I find very important, and that's an exercise into what this state-driven thing is. The view model also fills in for shortcomings, and I've just shown you the first shortcoming. We got a stupid model. It's not an intelligent model. We got to compensate for it in the view model here. It decouples the state and behavior from the view. The code behind is very tightly coupled with the view. You can't even instantiate the code behind class as a separate object, because there's partial classes in the background that need to be generated by Visual Studio. So you can't really test the code behind. And the code behind traditionally is what serves state to the view, and it's also what handles behavior for the view. So, behavior meaning we have a button or a link, and we have a click event in the code behind, and that's where our action is, right? Well, that becomes very hard to test. By doing it the MVVM way, we decouple this entirely from the view, and the classes can stand on their own, and they're fully testable. And once again, I'll say this, I said it before already, it allows, and I have an entire session, which I can't I'm not going to get to any of it today, but it's a session called Advanced MVVM, Engineering the UI Without the UI. And it's all about designing a UI. And in this session, I spent an entire hour designing a UI with absolutely no clue what it is really going to look like. I think of it in terms of the logic. What is it going to list? What am I going to expose to identify items in the list? What am I going to do with these items? What's going to change in different... There's a lot of action taking place, and I do it all by designing a view model layer. And in the last 15 minutes, I take a quick view made out of simple XAML, and I bind it to the view model, and the whole view comes to life. So it's a way of engineering the UI in an object-oriented fashion without even knowing a lot of intricate details about how this is going to be displayed. Keep in mind, that's not an extreme statement. There's a lot of times where you really do have to have some knowledge on how it's going to be displayed, of course. Now, this is an important statement, okay? And I say this because you're going to do some binging, some searching on the internet, and you're going to find a lot of definitions to MVVM, and you're going to find a lot of postings and forums that will tell you the goal of MVVM is to eliminate your code behind. How many people have read something to that effect? Well, that pisses me off when I read something like that. If the goal of MVVM is to get rid of your code behind, I can do that with cut and copy. You know, the elimination of the code. The goal is to separate things out of the code behind, but let that happen naturally. Let it happen organically. And in most times, your code behind is going to be reduced by 100%, or may not even exist at all to begin with, if you do things right. In many, many situations, you're going to have some code left in the code behind. That's very, very normal. Navigation code, for example, to jump from one view to the other. This is important because your views need to know what the view model is at runtime, not at design time. But your view models should never know what the view is. Your view models have no specific code in there to identify the view to which they're going to be bound later on. That's very important. And that's the number one reason why I actually like to put view models in a separate assembly. Because then my application, where my views are, references that assembly, but not the other way around. And that will let me, number one, resist the temptation to access views from a view model, and number two, make that impossible. If I feel really disciplined, like if I haven't had any scotch yet, I can just put them in separate folders in the same assembly, and I'll be fine because I know how to resist that temptation. But I rarely code sober, so I keep things in a separate assembly, and it just lets me not make mistakes. So don't make the goal of MVVM to eliminate your code behind. Let that happen, because it's going to happen if you do things correctly. These are rules of MVVM. These are the guidelines that I like to go by. And anything after these guidelines is really up to you. It's many different ways that things can take shape. So the view model should definitely have no knowledge of the view or any view for that matter. View models should not have view elements in them, meaning the view model should not know about the color or brush object. That's a specific view thing. Besides, if you do things right, a view model assembly can be reused by a Silverlight application and a WPF application. And those view-specific objects are specific to those technologies, so you don't want them in your view model. So your view model needs to be very loosely coupled. And the other rule is, I'm going to show you an example of each of these. View models can either expose their own properties, or they can expose the view, the model, as a whole. And I'm going to show you why you need to know these two things. Because the first one that we're going to do is the former. So I have something here called Superhero View Model. And Superhero View Model is a totally empty class, so we can't do a damn thing with this. But we need to bind this to our view. And right now our view is bound to the Superhero class, which has no intelligence whatsoever. It doesn't have any notification. There's no rules in it. There's no nothing. It's a dumb object. So what we're going to do is that we're going to give the view a new thing to bind to. But that new thing to bind to needs to meet a certain criteria. What's that criteria? It's got to have a name, and it's got to have a secret identity. Correct? So let's go over to our Superhero View Model class. And the first thing that I'm going to do is that I need a way, the Superhero View Model class, remember, this is a view model layer. It sits between the UI and the business layer. So it's going to encapsulate one or more business objects. So the first thing that I want to do is that I want to give the Superhero View Model class knowledge of whatever business object's coming in. So we're going to do this real simple with a little bit of constructor injection here. Okay. And there we go. Wrong. There we go. Let's create this real quick, and da-da. All right, so now we just found a way to inject our model into the view model, right? Now we need to give this class, which remember, it's going to become the binding source for my view. We're going to give it some properties. So the first thing that I'm going to do is give it a string called, what were they called? Hero and secret identity? Name and secret identity. Okay, so let's give it a string here. And this is going to return superhero.name. So all we're doing here is that we're wrapping. It's as simple as that. We're just wrapping, and in here, we're going to do this, right? But you haven't seen any real value here. I haven't shown you any real value. Oops. And the other one is secret identity. Now you see why I only did two properties, right? Okay. That's it, right? Now, if I make this class the binding source of my view, nothing has changed. Nothing whatsoever. But remember, we're here to compensate for where the model fell short. So, since the model is not doing any kind of property notification, I need to do that. So what I'm going to do is that I'm going to have my view model implement this interface here. And this interface, I notify property change, has one member that needs to be implemented, and that's the event. And what I'm going to do is that give this a quick little wrapper method, and this wrapper method will be called on property change. Did I just say sub? I haven't typed sub in years. Jesus. There you go. You see, I need a drink. Is alcohol free tonight at the party? It is? After it's not free, but it's free only up to a certain point, right? And after that, I think attendees are supposed to buy speakers drink or something like that. Okay, look what I'm doing. I'm doing a conventional property wrapping pattern, right? And it's property change event args, and I have to set property name into it, and there we go. So all I've done is that I've given, and you know what? This doesn't need to be public. It can be private. Because now what I need to do is that I'm going to say on property changed name, and here I'm going to say on property change see how that works? So now I've just given the view model the intelligence that I actually think the model should have had to begin with, but I can't rely on that. So now my view model is going to provide property notifications. So now if I go out here to my superhero, my main window, I instantiate my model, I got my model there, there's my view. Now I'm going to add to that superhero view model equals new superhero view model, and inject the model into the constructor. And now I'm going to bind the view to the view model instead. Now, let's do this. Superman and Clark Kent. Now, what happens when I hit change? Not a damn thing. What happened there? Object reference not set. Okay, so what is it? See what happens when you write code off the cuff? So now this is no longer the back-end data context, right? This is. There we go. So now if I hit change, it changes to Miguel. Once again, the view, when the data context property was set, the view tested that data context value to see if it implements iNotify property change. When it found out that it did, it wired itself into that event. So now the view receives notifications. And like I said, it's up to me to make sure that I call those notifications by doing this. Okay? Questions so far? This is your view model in its simplest form. It's all it is. It's not rocket science. It's a class that just serves things up to the view. Now, it can serve them in more than one way. It can serve them in individual properties like you have seen. But what if my model is a little more intelligent? What if the guy that wrote my business tier is a smart guy? What if he wrote a model that looks like this? This is a model, it's a business object. It has back-end variables. It has properties that have property notification. Not only that, check it out. It doesn't even try to notify on a property change unless it truly changed. So if it didn't change, why go through those resources? So it's a smart model. This guy's thought of a lot. I should buy him a drink. There's Arch Enemy. It's a sub-model. This is a more elaborate object model now. Notice this property is another object, right? So he got the Arch Enemy is a character in and of himself. There's a collection called a collection of power called powers. The power collection has one property called description that has notification built into it as well. Here's my static method to create the model. So as you can see, I can create a superhero called Superman, give him a secret identity, add powers to it, flight, strength, and X-ray vision, set a new character called Lex Luthor, make him the arch enemy of the hero. I'm creating a business model here, and it's intelligent because it's providing notification. So you should be able to, and I can guarantee you, you will be able to just take that character object, create one, bind it to a view, and if it changes in the background, it's going to update that view. But there's other reasons not to do that. Just because you have an intelligent model doesn't mean you should sacrifice the existence of the view model. Like I said, I believe that once you embrace MVVM, you should go all in. Either stay all out or go all in. Don't have some views that go straight to business objects or some views that go to view models, because it's just going to get confusing for you, and you're just going to lose track of your own code. So if I wanted to write a view model layer to wrap this, how would I do that? Well, here's the view that I'm going to bind it to. Well, let's take a look at this view. This view has all of these boxes that correspond to those properties, of course. It's got this list box here. Where's the list box? The list box is up here. Yeah, it's got a list box there to list the powers. And as you can see, look at the, where's the text boxes? I'm binding to properties, right? But notice the binding looks a little different. That's because I showed you this before I showed you the view model. So let's go over to the view model, which right now is empty. Let's bring the model into the view model, okay? So I'm going to say character. I'll just say model, and we'll create character model object. Let's go ahead and scope it out. Okay, so we just did a little constructor injection to inject our model into it. Now what we're going to do is that rather than duplicate all those properties, which there's no denying, it's a lot of work to do that, and there's times when you may want to do that, and I'll describe one after I'm finished with this example. The easy way to deal with an intelligent model and still adhere to the MVVM pattern is to very simply expose it like this. Now all I've done is to wrap it. And who's to say that my view may not need to incorporate the aid of 3 different model objects? My MVVM object my view model still becomes the single binding, but then I can have 3 properties that expose those 3 model objects because they're nice and intelligent, and still have one source of binding. So now to bind to this view model, my binding has to incorporate that property called model, let's say model.name. And I think it's pretty clear why I got to do that. I don't have a name or secret identity property in my view model. I'm just exposing the model as a whole. There's nothing that says you can't do that. But if you are going to do that, make sure that your model is doing property notification. Because if it's not, you're going to run into that shortcoming that we had at the beginning of the session. So in this case, I can do it. So let's go over to the main window. And in the main window, you know what? I'm just going to take this, comment it out, because I cheated. I had everything done here. So there's my character. There's my view model. I need to create a model. So character model equals, and I believe I had a create here. Yep, that creates everything. Of course, in real world, this would come from the database or something like that. And let's just inject that into there. And now I'm going to say view.dataContext equals view model and set my view. So now my view is going to be the character view, which is going to be bound to the view model, which is comic character view model, which contains the model and exposes that model through a model property. Make sense? Anything unclear about what I've done so far? I want to make sure. I'm trying to take simple steps. So, all right. So let's pray to the demo gods because I'm doing everything off the cuff here. Hey, look at that. Works pretty good. And if I put a button on here to change the model.name, for example, it's going to update because model.name, even though it's not in my view model, it's back one layer underneath, it provided property notification. So if you have an intelligent model, you can lighten up on your view model. Now, I promised you, I made the comment that there's times when even with an intelligent view model, you want to have duplicate properties. And the reason for that is really no different than before the world of MVVM, before WPF and Silverlight, even when we were doing just straight WinForms or ASP.NET, there was always the business scenario where you would need to undo something. In fact, a lot of us run to business frameworks like CSLA. Who uses CSLA here? All right, so CSLA's got an awesome undo functionality. You probably know this already. If you guys have not heard of CSLA, you got to go to lotka.net and download it. It's a great framework. And what I mean by undo is right now, both of these examples, the first one that had individual properties, but each one of them reflected back to the view property, or the second one, which just exposed not the view property, the model property, or the second example, this one, which exposes the entire model as one, still has one point of binding and one point of storage. The storage and the binding are exactly the same thing. So here, I'm storing everything in the model object, and that's exactly what I'm binding to. In this one, I lost my... In this one, I'm storing, where's the superhero view model? Here we go. I'm storing everything in the model object still. I'm just exposing it as individual properties. There's still one point of binding and one point of storage, and they're exactly the same thing. So as soon as you type something into one of the text boxes, it updates the back-end storage. And that back-end storage is what probably is eventually going to go to a database, right? So if you wanted to have some kind of undo capability, you have something in the middle. And what pattern you use is entirely up to you. So, there's 100 different ways you can do it, but I think it's pretty clear that you're going to need 2 points of storage. One that's going to be used for immediate binding, and one that it is the original model. And then only if you pass validation and accept, like with an OK button or something like that, then do you take the properties that your view is bound to and move them back into the properties of the business object and perform a save. And these are problems that we've always had. It hasn't changed. So now with a view model, we just have a little easier way of dealing with it because the view model has the capability of exposing its own properties with its own back-end storage, still accepting the model coming in through the constructor or through any other way. You can use property injection if you want. And the view model will just keep track of its own properties, completely untied to the model. And only when it comes time to validate and update the database does the view model code, using behavior, which I'm going to show you next, then go back to the model properties and update all of them. And the two things are kept separate until that point in time. Because if you don't pass validation, you don't want the database touched. You just want to have your own separate copy to work with at the view level. Did you have your hand up? Actually, the gentleman's asking if I had more than one model, would I still use the same pattern? Is that what you're basically asking? Well, you would need to, because if you had two business objects, like right now in this example here, I used a property called model, which I typically don't do. I would probably use a property called character or superhero or something like that. Because then maybe I have an entire business layer for my superheroes and another model for my villains. Now I want to expose them all in one view model because I have a page that's going to show both heroes and villains. So I would have two properties, one called hero, one called villain. Well, the XAML would change because the XAML needs to know what the properties that it's going to bound to. It doesn't care what the source is. It just hopes to God that it's going to look like this eventually. So if I were to change that model object to something called character, I would need to change that to character.powers, absolutely. Now, there's another way of doing it. Now check this out. I'm probably going to break my demo, but you know what? We'll take a shot in the dark. So check this out. The user control is set to the character, comic character view model object, right? We saw that. That's why those elements have to say model.this, model.that. You want to see what else I can do? And this may make it easy for you. What if I go to the grid now and say data context? Remember, everything has got data context. But the data context is a property just like any other. And it's subject to the same binding syntax as any other property. So now I can take data context and do this. Now the grid is bound to the model property of whatever the previously set data context is up the visual tree. So if that data context is my view model and that view model is exposing a model property, now the grid is bound to the model property. But now the data context has changed. And what does it change for? Everything from there and down its visual tree. So what am I able to do now? I'm able to come down here and get rid of this, 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 and get rid of this. And I should be able to see exactly the same thing. Yep. And now if you're worried about having to go back to the view and change things because your view model's in flux, now I've given you a syntax where you have one place to change it. Make sense? Sir? No. An object can only have one data context. And once you set an object's data context, an element's data context, its bindings are available, or its source is now available for bindings from it and down the visual tree. Now, anywhere down the visual tree, you can change the data context of any element, and now it's going to affect that one and down its visual tree, which is exactly what I did here. But you cannot have a label where content comes from one binding source and width comes from another binding source. It can only have one data context. That's where the view model comes in. Because if you really do have different sources that are going to have to serve your data binding, you wrap them in a single source. And that single source becomes your view model. It's exactly what I've done here, only I only have one source. Here I only have one model. But I can have 15 different business objects that came into this view model. And then I expose 4 or 5 different properties that obtain information from the different business objects. Now the view model becomes my single binding source for that view. But what's really behind the scenes is 15 different sources. So you have to wrap it. Another virtue of MVVM. Yeah. Say that again? Because I have multiple views to show you, and I'd rather have just one place to code. That's why I commented this and just created another view. He asked why am I doing everything inside the main window? Because I just think it keeps it encapsulated a little nicer. My main window has nothing but a placeholder in there, and I can just change whatever view I want to stick in that placeholder. It makes it easy for me. It's all about making my life easier. You could, but now you've changed it. Which one now? Where you want to? Right here. Yeah, you can do that, but now you're affecting the data context for the entire view. Sure. And now you've just changed the data context for that object and everything underneath its visual tree, which is exactly what I did. Well, you're always just going to have one. I mean, if you have two different view models in a view, first of all, I would consider that bad design. Second of all, your first view model will be at the top level, but then if somewhere down the visual tree you change to another view model, now this one's only good from here to here, and from here down it's the new one. But everything here has nothing to do with anything down here. There we go. Exactly. Exactly. All right, we got to keep moving. I'll take other questions on this topic towards the end. We got to keep moving. All right, so now I just showed you how state works, right? This is all about state, but now we got some actions going on here. We need some behaviors. So let's talk about behaviors. Behaviors are done even without MVVM, behaviors are done with something called commanding in WPF. Now, what commands allow you to do is encapsulate action and determination all in one. Rather than put some click behind a button where the click only gives you the action, what if you had to enable or disable the button based on different situations? That's determination of whether this action can take place. Well, commands allow you to do it all in one. And what commands do, this is the last session, right? There's nothing after this? If I go like maybe 5-7 minutes over, does that bother anybody? No, you guys are not in a rush to drink, right? All right, so the way commanding works is by writing a class that implements the iCommand interface. Now, the iCommand interface is an interface that gives us three things. The first one is an event, which I'll talk about later on. The two that are important are the execution and the can execute. And I think the name kind of implies what they're going to do. The execute is going to tell us, what this command is going to do. And this is kind of cool because it lets us separate this action from, in the old days we have to use the code behind, right? We've now separated it into another class where number one, it can be testable, number two, it can be reused. So what if I do something that I never want to see anybody do, and that is throw a message box from one of these things? Okay? And here I'm just going to say return true. This means that this command can always execute, which means that whatever button or link this command is bound to will always be enabled. Because out of the box, WPF and Silverlight gives us the ability to enable and disable buttons and links that are bound to commands based on intelligence that we provide in that command without having to do a lot of if-then stuff ourselves. So here's a very simple command. Now I'm going to take the view here. Let's see if I can do this in the next 5 to 10 minutes and then show you that last exercise. Now I'm going to take this view, which is very similar to the previous one that you saw, and I'm going to bind it to the command. But right now the command is a whole other class. So the first thing I got to do with this class is that I got to instantiate it. And that becomes a little bit of a pain in the ass because oh man, I didn't. Pain in the butt. All right. So now I'm going to, Eric is going to kill me. Say what? I'm at the donkey, exactly right. Or in my case, the elephant. As you can see, what I've done here is that I've instantiated my command. Anybody here work with resources? Okay, so when you put something inside a resource here, it's going to instantiate that class. So I got VM:save command. If you look up VM right up here, it's the namespace where this command resides, command_basics.viewModel. So now I can say, I want to declare a resource of the save command class and call it this. And what happens when this view gets rendered, it will literally instantiate an instance of that class and keep it under the name save command in camel case. Because now I can come down here to this button, and in this button, I can say command equals and give it a binding. Now right now my binding, this command is stored as a resource, so the syntax for a static resource is this. Now watch what this has done. Let me make this to start a project. It already is. If I hit save, here we are. It executes the command. If I were to take that return true and change it to false, that button will automatically become disabled. So I haven't solved the problem yet, okay? I'm giving you, that's why this project's called Command Basics. But do you understand how commands work? All a command is a class that implements the iCommand interface and provides execution and can I execute. And then you can bind an instance of that class. It has to be an instance of it, which is why I had to declare it as a resource in this case. You can bind it to a button. Now, let's say we're in a real-world scenario. We got this view model, beautiful view model that's bound. Is it bound? It is bound, right? Yeah, it's bound. There's all our data. And what if we want the save to literally take the contents of that view and save it out to the database? Out of the box, can we do this with the solution I've shown you? No, it's completely decoupled. This command class is totally separate. It has no knowledge of the view whatsoever, none. So there's a couple of routes that I can take to fix this. The first route, here's my view model. My view model is, and you know what? In the interest of time, what I'm going to do is that I'm going to switch to this project. Because now this project has stuff that is pre-done. Because I do want to show you a whole lot. So here is the same command with just a little bit of modification. What I've done here is that I've tied this command to my view model by allowing it to be injected into the constructor. Because now that gives this command class access, full access to every property on my view model, right? Which means that the action can now say so-and-so viewModel.model.name. You see that down there? Has been saved. That's just proof that I have full access to everything in that class, which means I can write database code here and take those properties, validate them, and send them to the database. But then how do I work with this command now? Well, in the view model, which is what's bound to my view, I declare it as a property. And here's, don't look at number 2 yet, that's going to be the next thing, okay? There's the property right there. Save command is of type save character command. And when I instantiate it, I send this, the view model, into it. You see how those two are tied together? That's one solution to the problem. Now, because now my whole view has already been bound to the view model, now that command is exposed as a property of the view model. This has given me greater encapsulation because now I've learned how to encapsulate not only state in my view model, but behavior as well. Now, this is not my preferred method, but this is the first one that I got to show you because you're going to see this out there. And there are reasons for doing it. If you really want to keep the two things totally separate because you think you're going to reuse this class. Now, right now, this class happens to be completely tightly bound to this view model because there it is right there. But I could always use an interface and kind of loosen the coupling a little bit so I can reuse the class by maybe a few different view models. And those view models maybe all expose a specific interface, and that's what I accept in the constructor. So I can use my own pattern for abstraction here. But because the command is now exposed as a public property, the view can be simplified a little. The view no longer needs the command declared as a resource. As you can see, it's gone. And the button just expects to have it as a regular property. So now it's just a typical binding, just like if it was a text box. Just happens to be that the command property is bound to the save command property of the view model, and hopefully the save command property meets the criteria of that command attribute, which means it's got to be a class that implements iCommand, and it does. So if I go to save character command now and look at what it does, it says so-and-so character saved. Let's see if that actually works. Superman character saved. What if I change this to that dude that fell off the Broadway show? Spider-Man. Spider-Man character saved. Now you can see that the command class is completely coupled to the view model and has full access to it, and it works just fine. But I want to take it one step further because this technique is kind of cool if I really, really need to encapsulate or reuse my command classes. But me personally, I'd prefer, I went through the trouble of writing this elaborate view model class. I'd like to have everything that has to do with the view in that one class. Having a separate command class is just going to give me too much crap to manage, okay? So I'm going to use a different pattern. And this pattern is known throughout the industry as the delegate or relay command pattern. You'll find two ways of describing it. If you deal with Prism, Microsoft Prism, they use the term delegate command, which is what I use. If you look at a lot of open source frameworks out there, like MVVM Lite or Josh Smith's MVVM Foundation framework, he uses the term relay command. They're exactly the same. And here's the way this pattern works. For this pattern to work, I got to find it first. Where's the delegate command? Here we go. You have a single class, one command class. This is your delegate command. What this command class does is that it implements the iCommand interface. So this is my command. This is the only one that I'm going to use. But how is it going to be usable for everything? Well, I'm glad you asked. Because the implementation of iCommand forces us to putting the iCommand interface here forces us to implement the execute, the can execute, and that event. And that event, all it does is that it requeries the can executes. And I'll explain that in a couple minutes. Now, what the delegate command does is that it has a couple of constructors here. And these constructors take delegates, function pointers that come into them. And those are going to be methods that are in your view model. So as you can see, look at this. This is the key one right here, this second one. The second one has an action delegate and a predicate delegate. I could have used func, F-U-N-C, same thing. So it's got an action delegate of T, I'll describe T in a second, and a predicate of T. The action is a void and lets you execute something. The predicate is a Boolean return and lets you execute something. And whatever two methods I sent into this constructor get widened, their scopes get widened into these class-wide variables. Because then down here in the execute and can execute implementation, I'm going to call out to the execute and can execute. Where's the execute? Here it is. I'm going to call out to the execute and can execute of the methods that you sent into it. Because now this allows me to store the actual methods that are going to serve as my execute and can execute code anywhere I want. And let the command know where they are when I instantiate the command. Because now in my view model can expose the command. I put both of them in here. Obviously, in real world, I wouldn't have both of them. In my view model, I have a property of type delegate command. Now, I don't want any arguments, so I'll describe the argument in a second. For if I don't have arguments, it's going to be of object, but I'll describe that parameter in a minute. So I have a property of type delegate command of object called save command 2. And when I instantiate it, I tell it what methods I'm going to send into that command, and these methods are in my view model. And now I can put the execute code here, and I can put the can execute code here. And you see how I can determine if I'm going to be able to execute or not? What's my true or false depend on here? If the model.name is empty or not. And I'm going to show so-and-so character saved. So now this is called save command 2. So I'm going to go out to my view and bind that to save command 2. Now watch this. Superman character saved. Now watch this. See how it just disappeared? It disappeared because on every property changed, as soon as I hit that key, it calls property change on that. On every property change, the command manager that's built into WPF is requerying all of the commands. That's what that event was for. It's requerying all the commands and rerunning their can execute. So that my can execute is getting hit every time that I do a property change. And in my case, I'm doing a property change on the key press, and that can execute is relying on the property behind the scenes of that text box. So as soon as I do this, it enables. I do this, it disables. And there is no if this, set the button.enabled equals true or false, which is the old way of doing it. It's completely decoupled. Pretty cool? Now, there's one other property that's available to you, and that is this property here, command parameter. And this is just another attribute, which means it can be bound to something, it can be hard-coded, whatever I want to put in there. The value in here, or the type that's in there, that you expect in there, is what this type is. So if you have a bunch of buttons, and they're all calling the same command, but each one needs to send something different into that command, that's where your command parameter comes in. because the value of that command parameter, the type of what you are going to put in there, if it's a string, it's always going to be a string, but it may be bound to something through a binding. So whatever the type behind that binding is what that type is going to be there. And whatever that type of the delegate is, that's the type that must be reflected here, because that value of that command parameter is what's going to get sent into these two methods. And what you do with them is entirely up to you. Make sense? Now, if that makes sense, I can do the final exercise, and we're cool. We got supposedly 7 minutes left, 8 minutes left, so I think we're just fine. Any questions so far? Freaking liars. All right, so I'm going to show you one last exercise. You notice I haven't gone back to the slides? Isn't that cool? I rarely do that. The slides show you a lot of the stuff that I've just showing you here, but rather than flick back and forth, I'm going to leave the slides for you, for your own reference when you go home and read this stuff on the can. You know that's what separates a geek from an alpha geek? Seriously. I used to ask the question, like, who considers himself an alpha geek, right? And like 3 people raise their hands. And then I defined it. An alpha geek is somebody that reads tech on the toilet. And then I asked the question again, and most of the guys go like this. And there's like 2 or 3 girls that are like, you know? All right, so I'm gonna show you a quick exercise here, and I got to give kudos to who thought of this, because it wasn't, I brought it to code. But there's a guy, a brilliant guy, a good friend of mine. He works for Microsoft. He's on the Patterson Practices team. His name is Carl Shiflett. And Carl used to be a buddy of mine. He lives down in South Carolina. Well, he still is a buddy of mine, but we used to see each other in the code camp circuit on the East Coast. And then he swallowed a blue pill, and he moved out to Redmond. And he's happy as hell, though. And Carl has become like just, you know, passionate about this stuff. He lives and breathes MVVM and WPF, and his blog is a great, absolutely great resource, and I got the link for it on this material. And Carl wrote a thing. Visual Studio provides you this series called In the Box. Anybody ever hear of it? Visual Studio In the Box? Yeah, nobody's heard of it. I didn't hear of it either until recently. But apparently they're going to be using it more and more. And In the Box, it's a plug-in to Visual Studio where it gives you tutorials on certain topics. And Carl wrote an MVVM in the box. And I got the link for it on the slides, so don't worry about writing it down now. And in one of his tutorials, he describes an exercise that he calls thinking in MVVM. And that's what I've brought to code. I've pretty much coded the exercise that he describes because I thought it was awesome. It was a great way to describe what differs MVVM from conventionality as far as code behind is concerned. And the one question that Carl asks in the exercise is, when the view has a requirement, think about the state that the view model needs to expose in order to satisfy that requirement. And what I'm going to show you is a quick before and after that reflects this. So in this before and after, I got this view here. Now the views are completely identical. As a matter of fact, I think in the main window I only show one, right? Yeah, I show one, and let's see. Good, before view. All right, so here's the before view. Now here's the exercise. The exercise is, we got this heading up there, and we got 2 buttons, and we got a label. The buttons are supposed to change the color of the label. One button will change it to red, the other will change it to green. So that this is my contact is going to change color. It doesn't get more stupid and useless than that, right? But it's a great exercise because we're changing the state of the view, and more importantly, we're doing it through 2 actions, and the state of what caused those actions needs to change too, because another requirement of the exercise is that when I press color 1 is now useless because the label's color 1, so I'm going to disable that button. And then when I press color 2 and the color changes, the enabling disabling is going to switch. Now, everybody in this room, whether you're Windows or web, is probably able to reproduce this exercise through conventional terms. So here's the color 1. As you can see, it has a click event. I'm changing to color 1. When the user control is loaded, I change to color 1 automatically. When I press button 2, I change to color 2. And then my helper methods, I change the foreground to green on one of them, to red on the other, and I enable and disable the appropriate button. Pretty simple, right? Now, how am I going to test something like this? I can't instantiate this class. This is virtually untestable. But it's still simple enough where you wonder, you know, why do I want to go through the trouble of a view model? Well, if I'm writing a quick 5-minute throwaway like this, I'm probably just going to do it like this, because I'm going to show you something and literally toss the code before somebody else sees it and starts spreading, wicked crap about me. But I want to do this the right way. I want to duplicate this exact same exercise through MVVM and see where we go with it. So what I'm going to do, first of all, let's run it and see if it works. So I'm going to say color 2, color 1. There we go. It works perfectly, right? How do I know if this is working or if I'm not cheating? Well, let's shoot over here and put a breakpoint on it. And I'm going to press color 1, and the breakpoint got hit. So we know we're in the before view. We're in the code behind, okay? So let's duplicate this exact same exercise with MVVM and see what the benefits of it is going to be. What I do is that I go straight to my view model. I typically start at the view model first. It's thinking about the UI in logical terms, not in widget terms. Eliminate the view from the equation. That's not always 100% easy to do or even possible, but try to eliminate from the equation as much as you can. And what I end up with is this exercise view model. Now, because all my view models do property notification, I do that in a base class. So that's why you see this. So building a view model framework little by little is a good idea, or using a pre-built one. So if I go to view model base, it provides something. This is where I can provide base state or behavior that all of my view models are going to want. And something that's common to all my views is usually a title. And I just put a title property in here. So every view model that inherits from view model base is always going to have a title property, and it can override it. Then my object base can serve as a base class for both model objects and view model objects, which is why it's one layer down, and that does the property notification. So just a very, very simple framework that I set up here, just a 2-class framework. Now let's look at that view model class. First of all, I override the title, return MVVM. So I have this title property. I hope I'm able to use it. I have these 3 other properties here because I like to put everything in my view model. I don't like to hard code literals in my views, because I'm going to localize, because I want this in Spanish or Chinese or whatever. So by having everything in one place, it lets me take this string that you're looking at right here and maybe refactor it later out to a resource file without having to worry about changing my XAML. So I'm putting all my literals on here. I got label caption, color 1 caption, color 2 caption. Nice encapsulated view model. I have this property here. It's a field called content color. It contains a string called green, and it's exposed by a property called content color, which exposes it and sets it and provides notification. So if anything changes content color, it's going to notify the view, right? Then I have a command called change color command, and it's a delegate command of type of string. So it's going to receive a string value in there. I don't know what that string value is yet, but it's going to receive that, right? So I instantiate the command. Where do I instantiate the command? Right here, new delegate command, and there's my 2 methods for execute and can execute. And where are they? They're down here. The execute takes that string that came in and sets it to content color. The change color command can execute takes the string that came in and uses it to determine whether it's going to return a true or a false. So if it's already equal to the one that's there, it returns a false. If it's different, it returns a true. So you see how I've kind of designed the logic in my UI without designing the UI itself yet? I don't know what the UI is going to look like, but I can tell you pretty much what it's going to show in one way or another and how it's going to behave in one way or another. So now that I have this done, now let's go over to the view, because the first view has a lot of crap in it, okay? It's got all of this hard-coded, which I don't like. And it's got these damn click events back here, which I don't like either. So let's get rid of this. Let's toss it in the trash. And let's look at the after view. And the after view has the labels. Well, everything is bound. The label, here's the label at the top, is bound to label caption. Even the view title itself. Here's the view title right here, which is this label up here, is bound to the title property, which came from my base class. Then the label that shows, this is my content, that's bound to a property of the view model. The buttons are bound to the change color command. And the parameter that I'm sending into that argument is going to be green on one of them and red on the other. Now, the last thing, that label, not only is the content bound, but the foreground property is bound as well. It's bound to the content color property. So when anything in the view model changes that content color property, it's going to reflect in the view. Who says that binding has to be only at like text equals? Here I'm doing foreground equals. Now foreground is expecting a brushes property, not a string. So we got a little bit of a problem here. And that means that that string, green and red, is not sufficient to satisfy the foreground property. So we have to use something that you haven't seen yet, and that's something called a type converter. And the type converter is going to convert one value to another. So the type converter is going to take whatever value is in the underlying binding source, run it through a conversion, and whatever that conversion returns, that's what it's truly going to bind to. And that's why up here, I have this class called string to color converter, declared as a resource. I named the resource because then in the binding of content color, I tell it I want to bind to content color, but not with its raw value. Take that raw value and run it through a conversion with this class, and then what that gets converted to, give that to me as the true binding. And I can show you that class right here. It's nothing but a class that implements iValue converter and provides a convert and a convert back. And in the case of convert, this is the value that's coming into it. So this is the string that's called red, that says red or green. And I take that string and I run it through a brush converter to actually convert that string literal value to the value of a brushes object. And then I do the reverse on the convert back. Because now all I got to do is bind all this stuff. I've declared the logic for my UI in the view model class. I bind it, and now whenever I press these buttons, it's going to fire off the command that's in the view model. It's going to send the word green or the word red into it. The view model is going to do something with that. What's it going to do? Well, it's going to change the content color property. Well, the content color property has notification, so it notifies the view that it's changed. So this is going to flip. And the code behind is completely empty. And if I run it, it works exactly the same. And one of the key things, because it was a little more work to get this right, but one of the key things is that now I have a separate project here called before and exercise tests. Because now I can write a unit test, and I can test content color notification, I can test property notification, I can test change color command execution, test command enabling. I can test state and behavior now simply by instantiating the view model class and working with it. I'm working with a view class, a view type class, but in logic form only. So it's fully testable. So it's a pretty cool exercise, don't you think? I give full kudos to Carl on this. He's the one that described the exercise. I just put code behind it. We did all the slides. So I just want to show you last thing here. So think in state-driven terms. That's what this exercise was. This describes the before and after here, so it's described in the slides. I showed you unit testing. I didn't show you view model first or view switching, but you have some code for it. As far as frameworks are concerned, one of the cool things about MVVM is that you can't do this with code behind, but you can start building a framework, and it's not only a core framework. Like, for example, in my framework, I have the object-based class. That object-based class has property notification built into it, and then it serves as a base for what my business objects are going to inherit from, which is model-based, and what my view models are going to inherit from, which is view model-based. And then the view model-based class has base classes for different views, because there's a lot of common functionality that views can share. If you're using an MDI interface, you may have some tool windows and some tabbed windows, right? Well, all those tabbed windows have a certain amount of common state, maybe a tab title or something, that maybe a tool window will not have. So I have a base view model class for those. And I just started building this core framework that's worked really well for me. Then you can take the framework concept and bring it down to your domain. So who's to say that you have to have just one view model per view and nothing behind the scenes? In this case, I got a customer view model, and then I have this customer profile view model. But the customer profile view model, I have three different views. One of them is for customer general information, one's for billing, one's for orders. And each one of them shares 2 or 3 properties that are the same in all 3 of them. So those view models come from a base class called customer profile, which has those. So it's designing your UI logic the same way you would design a regular business object model, just doing it at the UI. So this part of the framework is a domain level framework. This is going to serve no use if I'm doing something for race cars, but for customer maintenance, absolutely. So it's a project specific framework. So these are the frameworks. There's a lot of frameworks out there. There's Josh Smith's framework, is MVVM Foundation. There's one for Silverlight called MVVM Lite. Prism is my framework of choice. It doesn't really have a lot of MVVM stuff, it serves as a base to get you started. I have a framework that's on my website called Refraction that actually depends on Prism, so it extends Prism. So I'll leave it up to you to take the time to look at all those. Take the time, this is the best bullet point on this slide is take the time to do this because the design is going to be cleaner and it's going to be worth it. Take the time to not only embrace, but to set all this up properly because it's going to make your code really, really clean. It's going to bring a smile to your face and you're going to be a happier person for it. Your wife's going to like you a lot more. Let your view model evolve naturally. Don't be a diehard for, okay, what's my inheritance going to look like? Where's my base class? No, it's like any other code, right? When you write business objects, you just write the damn object. Then you write another object. Then you write a third one, and you figure out you're sharing some properties, so you abstract out to a base class. And you let your models evolve that way, right? View models are just that. They're just another type of an object layer. Don't forget your unit tests, because this is a big thing of why we do this, okay? This is Josh Smith's blog. It's a great resource for MVVM. My blog is .netdude.com. I think it's in the next slide. This is Carl's MVVM in the box for you to install in the Visual Studio. It's very cool. I suggest you check it out. There's tons of this stuff on the web. Just keep in mind, everybody's going to do it a little bit different. There's a lot of details in this model that are subject to interpretation and style. So just please keep that in mind. I can't believe I don't have my blog on here. Wow. All right, everybody close your eyes for a second. Okay. Like I said, I have my blog on here. First bullet point, as a matter of fact. So go to .netdude.com. I post stuff out there all the time. And if you have any questions, you can get a hold of me through that blog. My email's there. My Twitter address is on there. Everybody's got to follow me on Twitter now. Who follows me on Twitter here already? All right, I got like 1,000 followers, and frickin' Snooki's got like 57,000, and I got a real problem with that. So I'm going to leave it up to you guys, to everybody. I'm going to have 1,200, right? Or I don't think there's 200 of you here. But anyway, I hope you guys had a good time at TechEd. Thanks a lot for coming.